This video is going to show how to analyze component stress with smoke analysis in PSpice Designer. Spice simulation can be used to verify functionality before a design is produced. However, standard Spice simulation doesn't take design longevity or reliability into consideration. To ensure design reliability and prevent field failures, the stress on components should be analyzed to pinpoint and correct design weaknesses. Start by opening PSpice Designer. We will use a demo design for this example. If you don't have access to this design, you can download it from the how-to webpage. Select File, Open, Demo Design from the menu. The Open Demo Design window opens. Scroll down and select RF Amplifier. Click Open to open the design. The RF Amplifier design opens. View the list of tolerances and smoke limits in the schematic canvas. Ensure that the values listed match those shown here. Before we run stress analysis, we need to run a transient simulation. In the Project Manager, under PSpice Resources, Simulation Profiles, right-click Schematic 1 Tran and select Make Active. This will change the active simulation to a transient analysis. Select PSpice Run from the menu to start the simulation. The PSpice AD window opens to show the results. The input and load voltages are shown in original and rectified form. Close the PSpice AD window. Back in the schematic canvas, select PSpice Advanced Analysis Smoke. Smoke analysis calculates safe operating limits using component parameter maximum operating conditions and derating factors. If the PSpice Advanced Analysis Product Choices window opens, select the appropriate license and click OK. The result panel is already populated as smoke analysis has already been performed with the transient analysis. Green bars show values within 90% of their safe operating limits, and gray bars indicate invalid values. Right-click on the result table and select Hide Invalid Values to remove all invalid values from the table. This stress analysis was run with no derating, so the results aren't accurate. Right-click on the table and select Derating, Standard Derating. With the settings adjusted, we need to rerun the analysis. Select Run Start Smoke from the menu to start the analysis. When the analysis finishes, view the results. The collector-emitter voltage of Q1 has a red bar indicating that it is outside its safe operating range. Let's correct this by replacing the transistor. Right-click a cell in that row and select Find and Design. Minimize the Advanced Analysis window and return to the schematic canvas. A cross-probe results panel is visible with Q1 listed. Double-click the listing to be brought to its location. Press Delete on the keyboard to delete the transistor. Select Place Component from the menu to place a new transistor. The Component Explorer tab opens. Here you can place components with predefined Spice models as well as components from Symantec, Ultralibrarian, and more. Select the PSpice category. Enter 2N2219 into the search field and press Enter to search. 2 transistors are listed. Select the first listing and double-click to attach the component to your cursor. Click to place the transistor where Q1 was. Right-click and select End Mode. For consistency in the simulation results, let's change the reference designator. Double-click the reference designator and enter Q1 for the value. Click OK. After replacing a component, we need to rerun the transient analysis before performing smoke analysis. Select PSpice Run from the menu. The PSpice AD window opens to show the results. The amplitude of the plotted output is slightly higher than it was before. Close the PSpice AD window and reopen the PSpice Advanced Analysis window with the previous smoke analysis results. Select Run Start Smoke from the menu. All bars are now green, indicating that all components are now operating within their safe limits. Quickly analyze component stress to ensure reliable circuit behavior and that all components operate within their limits using smoke analysis in PSpice Designer. For more tutorials, visit us at resources.ema-eva.com and don't forget to like and subscribe to our YouTube channel.